He is a star. All right. How did you set up number one? Hey, stop. We have some learning to do today, so I need everybody quiet. How did you set up number one? 13C 3 times 39C2. The biggest mistake that'll happen here is everybody will get 13C3, and then some people will stop there. Because the only cards that are specifically mentioned are the diamonds, so you get those taken care of and you think you're done. But remember, it's a 5-card hand, so you've got to have the other cards, even though they're not discussed in the problem, you have to have them. All right, what did you get for number 2? 7 factorial, right? They're seated in a circle. Number 3, how many ways can all these books be arranged on a shelf? Ooh, what did you say there?
5 factorial times 4 factorial.
I like that one better. 9 factorial, this is number 3. 9 factorial divided by 4 factorial. How many things am I arranging on the shelf? 9. Does it say anything about they have to be grouped together? No. It just says there's 9 of them and you're arranging them on a shelf. That's 9 factorial. Why are we dividing? Because you have some identical items, right? So it's 9 factorial divided by 4 factorial. This is like having a 9-letter word with 4 E's in it. Okay? All right, what did you come up with for number 4? 15P3. 15 because there are 15 runners. P because first, second, third implies order. And 3 because you're picking 3 of them. So 15P3. And what about number 5? 7 factorial, 5 factorial. I like that. 7 factorial, 5 factorial. Because if the boys have to sit together, they count as 1. So the 6 girls and the 1 clump of boys, that's 7. But the boys can be arranged 5 factorial ways. How do you feel about that, okay? All right, let's go to the back of page 3. There are a couple more quizzes. I'm just trying to think about what your quiz next time might look like.
Yeah.
Alright, let's hear from some people we never hear from. Just saying. Do you have an idea for problem 1 at the top?
Sue? We're trying to think there. She'll say no.
It would be, did you say a P? C. It's a C problem. Definitely it's a C problem. You want to contain 2 hearts. So, shh, I can't even hear her. Start with that. How many hearts in the deck? Yep, 13C2, that takes care of the hearts. But remember, it's a 5-card hand, so what else do I need? 3, because there's 3 more cards. 39C3. There's the answer to number 1 at the top of the page. Now, when she's given the answers and I'm writing them on the board, they seem easy. You got to be able to figure these out on your own. 13C2 takes care of the hearts. 39C3 takes care of the 3 other cards. Agreed?
Agreed.
All right. Number 2, cripe. How many ways can I distribute 4 identical pencils in a class of 20?
20, do it at 4.
Exactly. Everybody understand why it's 20C4?
Because they're all the same.
They're all the same, so the order of distribution is not important. They're all the same. How many ways can I select a batting order for my 9 players?
Maybe one.
No.
Is it
9 factorial would be one way to think about it, because if you think about what you're doing, 2, 3, 4, 5, 6, 7, 8, 9, you got 9 slots, right? How many choices? Here are my 9 players. How many choices do I have to bat first? 9, and then I have 8, 7, 6, and so on. Anybody think about this differently? 9 factorial is fine. That is the correct answer, but there's another way to write the correct answer. How about 9P9? There are 9 kids. I'm going to pick all 9 of them, and the order that I pick them matters. I mean, it's called a batting order. And if you type this into your calculator and you type this into your calculator, they're the same thing. So you could think about that either way. How many ways can 4 identical, 3 different, 5 identical be arranged on a shelf? Here we go.
8, 12.
What are you starting with? 12 factorial.
divided
Kids,
by
you're arranging them on a shelf.
9.
That's in a line. There are 12 books, 12 factorial. But what? We're going to divide by 4 factorial and 5 factorial. I want you to type that in. I remember when I gave this quiz, a bunch of kids set it up right, didn't get the right answer. So make sure when you put it in, you're putting those parentheses when you're dividing by more than one thing. Big number, what'd you get? 166,320?
Yup.
That what you got? 166,320 is what you need to be able to get. If you're not getting that, then you're typing it in wrong. And we need to figure it out. How many ways could 7 people be arranged in a circle?
6 factorial.
6 factorial. So there's 7 people. Yeah, one less. Yeah. All right, number 1 below that, period 4 quiz. How many ways can 3 algebra students and 4 pre-cal students be arranged in a row if the algebra students must sit together?
12.
What do we start with?
5
We
factorial.
start with 5 factorial. Now, stop. How many things are you really arranging? You're really arranging 4 pre-cal students and a cluster of algebra, right? That's 5. But what about those algebra kids? They can be arranged 3 factorial ways. So that's the answer to the question. How many ways can I love math be arranged? Start with 9 factorial. That's how many letters you have, period. Now, are any of them duplicates? Oh my gosh, there's no. Okay, so the answer is 9 factorial. How many ways can 1st, 2nd, and 3rd place ribbons be awarded to a group of 10? 10P3. Perfect. How many 5-card hands contain exactly 3 aces? Wait. Exactly 3 aces. So that would be 4C3 and 48C2 multiplied together. remember, this doesn't say 3 diamonds. It says 3 aces. So there are only 4 aces in the deck, and you're going to pick 3 of them. So 4C3. And then there are 48 cards that aren't aces, and you're picking 2 from that pile. Got it? How many ways can 10 people be arranged around the dining room table?
How many seats the dining room table?
Well, we're going to just seat 10 people around the dining room table. 9 factorial. 9 factorial. Alright, that's enough review. Let's do a couple new things. That's what your quiz is going to look like tomorrow. Okay? That kind of stuff. Now, today, we are going to talk about binomial expansion and binomial probability. Now, what do I mean by that? Well, let's start with binomial expansion because it's something you're familiar with. No, we're taking notes. I mean, there's some of this in your packet, but we're taking notes first. All right, so here we go. X plus y to the first. Okay? Now, okay, you need to stop the chatter. This is new stuff and we don't want it to be confusing. X plus y to the first is just x plus y. Everybody knows that. Now, I hope that you also know that x plus y to the second is x squared plus 2xy plus y squared. Because if I'm going to do x plus y to the second, it's a FOIL problem, right? Right? This is called binomial expansion. I have a binomial, I'm raising it to a power, so it's getting expanded. Now, what about x plus y to the third? Well, could you FOIL that out? X plus y, x plus y, x plus y? Sure you could. And I've done it lots of times, so I know the answer is going to be this. Now, what about x plus y to the fourth? You could do the same thing. Now, at this point, you're thinking either Mrs. Ford is incredibly brilliant or there's a trick to this. And I'll tell you it's not the former. There's a trick to it. There's a trick. Something's going on here. And we're going to discover what the trick is. Okay? So we're going to think about, what about x plus y to the fifth? Now, I think there are parts of this that you can fill in. I think all of you can tell me what I'm going to start with. Yep. And I bet you can all tell me what I'm going to end with. Okay. Now, what about in between there? Do you have any thoughts on what might be in between there?
5x to the fourth.
X to the fourth y here on this term? I think he's right. And the next one would be, oh, there's a number there. We'll talk about that in a minute. Right now he's doing letters. What would be the next thing?
X cubed.
X cubed.
Y cubed.
Squared. Y squared. X squared. Y cubed. X y to the fourth. I don't know how much of that you actually picked up on. I know some of you did. But what's happening is, as we go down the terms, look at your x exponents. What's happening to your x exponents as you go down the terms? They're going down by 1. And what's happening to your y exponents? They're going up by 1. Within each term, if I was raising to the fourth power, within each term, my exponents added up to 4. When I'm raising to the fifth power, within each term, my exponents add up to 5, right? So that's how we handle the letters. So the only thing we haven't talked about is these coefficients that are on some of the terms. You're pretty confident that you got the first one and the last one figured out, and you do, you're right. But what about those ones in the middle? Any thought on what those coefficients might be? Well, we think this one's probably a 5, and we think this one's probably a 5. And you would be right about that. What do you think about those ones in the middle there? Are they 12? No, they're not. That's an interesting guess, though. In order to see what they are, let's look at just the exponents, or just the coefficients, okay? So the first two coefficients were 1 and 1. Then we had 1, 2, and 1. Then we had 1, 3, 3, and 1. 1, 4, 6, 4, and 1. I'm going to erase some of this now because we already talked about it anyway. This is a very famous triangle of numbers. This is called Pascal's triangle, or sometimes the arithmetic triangle. Blaise Pascal was one of the really smart guys. Had a very interesting life. We'll talk about that in a minute. But anyway, this is called Pascal's triangle. Now, you've already told me there's a 1 here and a 1 here, because we're doing this row of numbers. Here is what's happening. To get this 6 right here, these two numbers were added together. To get the 4, those two were added together. So you told me this number would be a 5, and you're right. But this number won't be a 12, it will be a 10, and a 10, and a 5. So these coefficients are 1, 5, 10, 10, 5, 1. So now if I said to you, let's do x plus y to the 6th, you can do it. What are your coefficients going to be if we do the 6th row? Well, we got a 1 here, then we'll have 6, 15, 20, 15, 6, 1. So those are your coefficients. So I'll go ahead and write them down. 1, 6, 15, 20, 15. This is why it's called binomial expansion. These things can be so big. So there are your coefficients. Now we need the letters. So we're going to start with x to the 6th, go down to x to the 5th, 4th, 3rd, 2nd, 1st. Now technically this is x to the 0, but anything to the 0 is 1, so I don't even write it down. You can if you want, but you don't need it. Now what about the y's? Well, they do the same thing, but they start down here, right? 6th, 5th, 4th, 3rd, 2nd, 1st, and 0. And then we just fill in the plus signs, and we're good to go. Okay, is that okay with everybody? Now, suppose that the question was not find x plus y to the 6th. That's what you just did. That's the question you just answered. Expand x plus y to the 6th power. Okay, you did that. Suppose the question was find the 4th term of x plus y to the 7th. Now, each of these is called a term. So what we're doing now is instead of finding the entire list, we're only going to find the 4th one in the list. Okay? So we need a coefficient and an x and a y. Every term has a coefficient, an x and a y. Now, we're doing x plus y to the 7th. So we need the 7th row of our triangle, but we don't need the whole row. We only need the 4th one. So 1, 7, 21. It looks like the 4th one would be 35. So your coefficient is 35. You gotta have an x and a y in there. If you wrote the whole thing out, this would be x to the 7th, 6th, 5th, 4th. So it's going to be x to the 4th. And these exponents have to add up to 7. So if that's a 4, this one has to be a 3. You know pretty good about that. That's not too bad, is it? All right, I'm going to add 2 things to it. Let's do another problem. Let's suppose, where's the first part of my triangle there? Let's suppose we want to find the 3rd term of 2x minus 3y to the 5th. All right, now it's a little bit harder because it's not a plain x and a plain y. But the idea is exactly the same. We're standing to the 5th, so we'll go to the 5th row of the triangle, which is right here. Your answer is going to have a coefficient, a power of 2x, and a power of negative 3y. Before, every term had a coefficient, a power of x, and the power of y. Well, now the binomial is bigger. So when I do my FOILing, I'll be multiplying 2x and negative 3y. Now what's my coefficient? Well, I'm going to be the 3rd term in the 5th row, so it's 10.
Why is it
5th power, 3rd term. Pound. Now, if you were doing the whole expansion, right here would be 2x to the 5th, right? This is 2x to the 4th. So this is going to be 2x cubed. And if that's a cube, this one has to be a squared. So now we got a little arithmetic to do. What's 2x cubed? 8x cubed. So I have 10 times 8x cubed. What's negative 3y squared? 9y squared. So now I'm going to multiply it all together, and my answer is 720 x cubed y squared. Okay? So now it doesn't really matter what the binomial is. You can expand it no matter what. This question always shows up on math contests. Always, always, always. Because they think they're being so tricky when they ask a question like this. Find the 6th number in the 20th row of Pascal's triangle. Now, once you know the pattern of how to find these numbers, anybody can find any number of Pascal's triangle, right? You know what to do. You just add the 2 above. This is an issue because they want you to go all the way out to the 20th row. Now you may think that's no big deal, but we're right now we're at the 7th row. So imagine going all the way to the 20th row, how big that's going to be. And the numbers get big, so big you can't add them in your head anymore, so now you're using your calculator to calculate them, and it just takes forever. They always put this on the math contest because every kid can figure it out, but by the time you figure it all out by hand, your time's up, and you haven't gotten to the rest of the questions. But the smart kids taking the test know this. Take your calculator out, and I want you to type in a few things for me. I want you to type in 66, 65, 64, 63, that'll be enough. Just type those in for me. The C button is in the math probability. We've been talking about that for days. Well, not for days, but we certainly started yesterday.
It doesn't like where it is.
I wasn't here yesterday.
Well, you know what? Then take care of business, buddy.
Should've watched the video.
Now, what have you noticed about 66 was 1, 65 was 6, 64 is 15, 63 is 20. Any guesses about what 62 is? 15, 61, and 60. There they are. So the numbers in Pascal's triangle are nothing more than the combination numbers. So if you were interested in the 20th row of Pascal's triangle, the first number would be 20C20. Okay? The second number would be 20C19, 20C18, 20C17, 20C16. Which one did I want? The sixth number, 1, 2, 3, 4, 5. So the sixth number is 20C15. Well, go ahead and type that in and you'll see what I mean about getting big numbers. 20C15 is what? 15,000 and something. That is the sixth number in the 15th row of, or the sixth number in the 20th row of the triangle. So when we start doing the problems that we're getting ready to do, you can find your coefficients either by using Pascal's triangle, and I often just write it down up in the margin of my paper and refer back to it. But you can also find your coefficients using combinations if the triangle becomes too unmanageable. All right? Now, you're sitting here thinking, you know, Mrs. Ford, I'm so glad I came back from lunch today. This is so amazing and awesome, but I don't understand what this has to do or how it connects to what we've been talking about. This doesn't. That does. How does Pascal's triangle connect to what we've been talking about? Well, when Pascal first wrote down the triangle, it had nothing to do with expanding binomials. You see, Pascal, like most of the really smart guys back in the old days, was kind of excluded from society. He ran with a bad crowd. Many of them did. Many of the great ones ran with bad crowds. Pythagoras, you know the Pythagorean theorem? He was ostracized from Greek society and actually started a cult called the Pythagoreans. And they lived outside of regular Greek society. They were so smart, they just kind of had their own thing going. Most of them were drug addicts. They were just different people. Well, Pascal ran with a bad crowd of people. He was friends with some bad dudes. They were called gamers, which meant they were gamblers. And they were kind of the ones that you would, in movies now, you see them sitting around on the street corners in Brooklyn and they're throwing dice.
Shooting dice.
Yeah. This is this crowd that he ran with.
Hello.
So they knew he was really smart. So they came to him and said, Pascal, old buddy, show us how to win. Show us how to beat the odds. You understand the mathematics. We don't. Help us win. And that's where the triangle was born, and that's where I will pick up the story next time. Okay. So you will have to live in anticipation.
Wait, so you're teaching me how to count cards?
Can't do drugs?
Yep, that's what I do.